So, I was expanding on the questions again because I wanted to test this with other AI models at least. And this last iteration that I have, I'm just going to read it and I'm just going to read you the results and that's it. So, check out the past previous videos that I just posted. I'll link them down in the description for more info of this whole thought process and everything else. But it's just bringing up ideas, just theory crafting. So the question is, since thermodynamics plays a role with the singularity density of a black hole tending toward infinity due to the effects of vacuum energy and vacuum pressure, effects on the Higgs field surrounding the singularity as it rotates near the speed of light being fueled by the forces from the nuclear and quantum electromagnetic reactions spontaneously occurring within and around the singularity, though certain interactions are limited by the gravitational force opposing and overcoming them or overwhelming them, while the rotational forces from the singularity as it rotates near the speed of light, which causes the frame lagging or frame dragging effect around it, which maintains the gravitational pull of the event horizon, while mitigating the effects of the forces of electron capture interactions due to the density from the sum of frame drag and force as the sum of quantum gravitational pull of the rotating singularity, while matter being attracted towards the singularity due to magnetic forces and the frame dragging mentioned from the rotational force of the singularity, which overpowers the beta decay rates and the repulsion force from the strong nuclear force of what's within the singularity being suppressed by the forces responsible for maintaining the density and pressure towards the center of the black hole, following the Bose-Einstein condensate effects used to explain analogs for the state of the singularity of a black hole, as with sonic black holes, for instance, while the forces from annihilation of particle and antiparticles within the singularity and event horizon, which creates various other particles alongside the neutrino and radiation evaporation from the event horizon relative to the total particle mass and the volume of the singularity being driven by the sum of the forces as they overwhelm the neutron density limit within the singularity, with density tending towards infinity towards the center of the singularity, then the outer surface area of the singularity. So, oh my god. So it tends towards infinity, toward the center of the singularity, more so than the outer surface of area of the singularity, as black holes' mass is inversely related to its observed temperature alongside its evaporation rate. Could an equation involving the understanding of these forces describe or discover an equation for quantum gravity, or the sum of quantum gravitational force relative to local causality and the output gravitational waves through space if converting the mass term into Newtonian gravity and general relativity with the integral of density from 0 towards infinity multiplied by the integral of volume from infinity towards 0, and be like the integral of mass or something like that? And that's looking at the equation for mass density, or well, for density being mass over volume, or if you look at it from the perspective of mass, it's density times volume. So, I mean, obviously, that whole process is broken, but if we observe, so let's say, the integral or a derivative function of Newtonian gravity and maybe Einstein's general relativity, replacing those terms, maybe using partial derivatives, partial integral, something. I mean, the last time I checked this before fixing some other issues with the question was that it's not necessarily mathematically impossible. At least this idea is not mathematically, physically possible in concept. But at the same time, if we want to figure out the whole theoretical idea of infinite density at the singularity, I mean, obviously, it's not truly infinite, it's just tending toward it. And same thing with the volume. The volume isn't actually zero, but it's tending toward it. It's compressed. It's constantly compressed to maintain that density, but that unit of mass still exists in some way, or is so dense to a point that again it affects the Higgs field itself, and thereby kind of breaking reality and everything else, etc. All right, that's the question. That's what we got so far involving all these forces, and this last one, answer, at least from Google so far. And we'll experiment with other AIs later because this is a big ass question, and I don't think any of you people could probably answer it. I mean, it's it's an idea, and I mean the simple answer is obviously going to be no necessarily, but trying to at least figure out what's what and trying to see where the holes are, where the cracks are, where the issues are, so we can figure out what this is. All right. Obviously, Newtonian and general relativity and stuff like that. I mean, general relativity points toward infinite density of the singularity. So let me read this, and I mean, it'll repeat that same point. So this question outlines a highly speculative theory combining multiple complex and unproven concepts about black holes, particularly proposing a black hole singularity could function as a Bose-Einstein condensate. While intriguing, this is not a accepted or established scientific theory. No definitive conclusion can be reached without a confirmed theory of quantum gravity. Understandable. But here's an analysis of the questions premised based on current physics and ongoing research. So infinite density, it's a singularity. General relativity predicts an infinite density. This is the idea that we're going off of, okay? It predicts toward the center of a black hole. And this is, I mean, the center of the singularity, if you will. I mean, the singularity is part of the center, but it's not the exact center. So when we think of infinite density, we're thinking of the exact center point, obviously. That's the point where general relativity breaks down and where gravity in our 3D space doesn't work, because this is, I mean, the amount of gravitational pull, the force itself coming from a black hole is immense. It's insane. So obviously understanding where it breaks, good, good. All right, a viable theory of quantum gravity is needed to properly describe what happens at the black hole's core and resolve the paradox of infinite density. That's what we're trying to do. So Bose-Einstein condensate model, the idea of modeling black holes as BECs is an active area of research in theoretical physics. Some studies suggest that black holes might be a BEC of gravitons, offering a quantum explanation for properties like entropy. However, this is still a speculative approach and not a proven reality. So that's interesting. I mean, when we talk about the neutron limit, the density limit, right? It's, if something is so dense to a point that it can't exist anymore, right? It's so condensed. It's just like, you condense coal to a certain point, it turns into a diamond. You can make diamonds and completely negate the time factor, the natural creation of diamonds. You can make artificial ones. It's that idea. It's like, it's not coal anymore. It's a diamond because of the density. It's, I mean, that might make sense, that it's so condensed to a point that the particles that exist within the singularity are just gravitons. And maybe gravitons, and what's escaping is neutrinos. So neutrinos must exist in some way if they're escaping through the event horizon or past it or whatever. But as we observe, there is evaporation going on. The black holes, I mean, it takes a long ass time for them to shrink, but they do shrink. Okay? So there's some escape, and the verdict seems to be Hawking radiation, obviously, and neutrinos, or particle and antiparticle pairs. Something is able to escape the singularity. Understanding the size relative to the, the density, etc., will probably help to understand where quantum gravity is in the whole process. Because, I mean, if something's so small to a point where the quantum gravity and even just gravity itself can't affect it, right, doesn't interact with it, must be small. Must be maybe a photon, which, I mean, would be the Hawking radiation. So gamma rays, etc., the photons of certain wavelengths carrying a certain amount of energy. That's what makes them radiation. And then you have neutrinos, which is basically a very, very, very tiny charged particle that's relative to an electron, essentially. That's just like the summation of it. It's way more intricate than that, obviously. Well, let's see, the Higgs field effects. So this other aspect that I mentioned, the behavior of the Higgs field under extreme gravity is not fully understood, but it is a focus of some theoretical work. One proposal suggests that near a singularity, the Higgs field could behave in a non-perturbative way, potentially leading to geodesically complete space-time that extends beyond the singularity. This is an unconventional idea and is currently being debated. So, I mean, obviously, the singularity bends space-time. It does stuff to the Higgs field, right? And this is something that's just been trying to figure out, it obviously has to do with the density. It has to do with the attraction forces that are governing the black hole's existence, right? And we have quantum interactions and vacuum energy. The interaction of vacuum energy with the extreme gravity inside a black hole is another speculative area of research. Some models suggest that black holes could be a source of dark energy, but this is still a developing area of cosmology. Similarly, the role of quantum electromagnetic and nuclear reactions within the singularity remains theoretical, as our current physics models are inadequate to describe these conditions. So this is why we're asking these questions about, neutron density, the whole idea that tendency towards infinite density is going to dictate form. I mean, obviously, it also dictates temperature. It coincides with thermodynamics, right? That's, when you condense something very, very, very much so, you put a lot of energy to condense it, it turns into thermal energy. That's, and what we observe with evaporation, as well as the mass being inverse to the temperature, which is next, actually. So let me finish the frame dragging. This is the next effect. The frame dragging and gravitational pull. Frame dragging, the lens thawing effect, is a known consequence of general relativity for rotating objects, right? The general relativity of gravity. So it's there. It is an effect. It is most pronounced near a spinning black hole. It does influence the motion of surrounding objects in spacetime, but the specific dynamics of how it might mitigate or overcome other quantum forces like beta decay or the strong nuclear force in the way described is speculative. Understandable, but again, density, this is why density and the whole idea, it's again part of general relativity, is theoretically the center of a black hole is infinite density. So it's relative to that. And next is evaporation and Hawking radiation. Black holes are known to lose mass over extremely long periods through Hawking radiation, which originates from quantum effects at the event horizon, not the singularity itself. The rate of evaporation is inversely related to the black hole's mass, meaning smaller black holes evaporate faster and have higher temperature. So that's where thermodynamics comes into play. Ultimately, the scenario described is a series of hypothetical ideas grounded in existing concepts like BECs and thermodynamics, but extrapolated beyond the current limits of scientific verification. Without a complete theory of quantum gravity, we cannot definitively say what occurs inside a black hole singularity, nor can we confirm or deny the complex interactions proposed in this question. You can't confirm or deny it. Can't deny it, at least. So this somewhere it's there. It's there somewhere. It just needs more work. So that's what I'm gonna do. I'm gonna look more into this stuff and learn more about this, and hopefully we'll have time to make like a equation tier list or something that is relative to all this, and also look at our model. One of the other questions when I looked up before, just to at least show you guys, I mean, why a complete equation remains elusive. So the combination of all these elements, this is a different question, but I mean the point's still the same, remains the same for the most part. So incompatibility of frameworks, I mean, attempts to combine elements from several disparate fields. However, general relativity describes gravity on a large scale, which is what we discussed here. Obviously, the observable scale that we see, the general relativity works, right? And the 3D reality that we exist in. Obviously, black holes is an interdimensional force where understanding the 4D plane, or 4D, whatever you want to call it, really. No, I wouldn't say plane though, it's like 2D. But understanding the 4D and the 2D, as well as like integrals, derivatives of the mass itself, right? The change in mass, the evaporation, obviously it's a slow rate, and then as it gets smaller, it increases exponentially. Because again, smaller masses, higher temperature, it evaporates faster. It's more stuff going on in the singularity that's allowed, but the density is still going toward infinity. And at least closer to the center of the singularity, it's more toward infinity than it is on the surface area of the singularity, so to speak. That's my idea, at least, as of right now, or as of a while, honestly, a few months. So, but I mean, it's two frameworks, mathematically and conceptually incompatible. Certain extremes, like inside a black hole. I mean, this is where inverses come into play. So mathematical inconsistency as well, standard attempts to quantize gravity as a field results in infinites that cannot be eliminated through the process of renormalization. So that has to do with when we look at electromagnetism, and once you get past a certain point for GeV or electron volts, whatever the value is, then the wave equations break, right? That's where the mathematical inconsistencies exist. So no single theory. Physicists are still working on unified theory of quantum gravity, with the most prominent candidates being string theory and loop quantum gravity. Neither have been experimentally verified, and they offer different approaches to resolving the fundamental incompatibilities. Now, string theory is probably onto something, as I discussed in the previous video that I posted, linked down below. I mean, if you picture, obviously, a black hole is rotating almost at the speed of light. If you picture something basically hitting the surface area of that, and then the moment after it hits that, I mean, if it's rotating at the speed of light, that thing is stretched. Just, the whole time dilation effect, the mass, like, stretch effect when things approach the speed of light, right? When complex forms of matter approach the speed of light, they stretch out. That whole effect that is part of general relativity and Einstein figured out, that exists as soon as something makes contact with the singularity. I mean, well, obviously, anything that gets that close is already breaking down in the particles at that point. It's not physical, like, complex matter at that point. But essentially, as soon as that, let's say, like, a neutron makes it through and hits that, it's hitting the surface area while it's going almost at the speed of light. And obviously, if it's probably rotating almost just at that speed, but as soon as it does, it's going to stretch. Because, I mean, the closer toward the center, I'm sure it's going to be rotating. I mean, with, again, rotational forces, centrifugal forces, inertia, torque, all that stuff, that is still relative in terms of black holes. I mean, there is spin, same thing with neutron stars and other things of immense mass and density, right? Because of just all these different effects, what's able to occur within the singularity and what's not able to occur, right? And that's why we're looking at this through the lens of density, and density going toward the center, because general relativity supports that. So we can find a integral or derivative form of the general relativity equation, maybe that can be worked in somewhere to make the connection to the quantum space. Maybe. Or maybe there's something in that equation that exists that we just haven't noticed yet or haven't tried to do. I don't know. I don't know what has been explored, what hasn't been explored. But it's at least good to have an imagination, to be creative in this sense, so we can go over these different aspects. Now, another thing is unobservable scales. Obviously, we can't see inside of singularity. It's all speculative, no matter what. We can't exist inside of singularity. Nothing can really meaningfully exist. That's the whole part of the information paradox, is understanding what goes in and what's coming out from what was going in, which you can't, because you can't observe it. So quantum gravitational effects are only expected to become significant at the Planck scale, around 10 to the negative 35 meters, which is far beyond the reach of current particle accelerators and other experimental equipment. So, I mean, obviously, from particle to particle, it's meaningful, but it's only meaningful at that scale. And of course, the sum of that force, particle to particle force and interaction, the gravitational waves, right? That is meaningful in greater space. And that's why this is very, very difficult to figure out, because it's, I mean, again, string theory, it's a good idea. I mean, obviously, things happening in waveforms, that is how energy is. That's how sound works. It's just through an atmosphere buffer, right? The atmosphere is buffering sound energy through space, and that's why we're able to interact with sound a lot easier than light. Especially since, I mean, it's direct energy influencing the atmosphere and the environment, whereas, I mean, photons and electrical energy and stuff like that is in smaller scale for one, and I mean it's more physically visibly observable for two, but it's not as, when it comes to reality and stuff and how energy works and everything and how energy takes form, it's way more complex. So also we have loop quantum gravity. This theory proposes that space-time itself is quantized with a granular or loop structure at the Planck scale. Unlike string theory, it is not a unified field theory and focuses specifically on quantizing gravity. So that's kind of cool. I mean, these two maybe can work in tandem and you can figure it out, but yeah, naturally incorporates a spin 2 graviton particle. It is a leading contender for a theory of everything, but has not yet produced testable predictions. I mean, if that's the tough thing too. If you can't observe it, then how are you going to test it? So black hole complementarity and firewalls. These are theoretical attempts to resolve the information paradox, as we just described, which is related to your points about black hole evaporation and the fate of particles falling into a black hole. These hypotheses propose different mechanisms for how information is conserved when it falls past an event horizon. So, I mean, kind of there, but not really. But this is where we're at. This is at least all the different factors within the equation and all the different possible relative ideas that could explain quantum gravity in some way, or at least will almost completely explain black holes. But at least this is my hypothesis and proposal to you all. Then you can look into it yourself. If you know more about this, you can maybe try to piece some things together, or maybe it'll inspire you to look into other stuff as well for yourself, as much as constantly looking into this stuff inspires me every day. It's very intriguing, and I mean, the point where I don't have a whole team of scientists to refer to, I don't have peer reviewers or anything else of that nature. I'm not in school. I can't afford to even go to school. I don't have the time to do it anyways. I have a lot of obligations in real life and barely hanging on. But at least to put these ideas out there is the best that I can do, and to take the time to learn more for myself, like learning more about, things at the Planck scale, thermodynamics. It's just, I'm about Bose-Einstein condensates. I just learned about that today and learned that, that's a relative factor. And now that's also involved with this whole idea and trying to establish where we are at realistically with understanding quantum gravity, what we do understand, what we don't understand, as well as the different aspects of particle physics that may exist or may not exist within the singularity of a black hole. And I mean, obviously, quantum gravity is there, and understanding what works in tandem with it and what doesn't, what promotes quantum gravity and what doesn't, based on, I mean, black holes limit the amount of forces that can interact, right? That can interact with particles because of that intense density. So we can use that to maybe find something there, which granted, yes, it's the most extreme case, but it exists. And it's the most extreme case that, I mean, supermassive black holes, that's, we observe those haven't eaten the entire universe yet, those haven't exploded, those haven't done anything, then what else is there? That's as extreme as you can get. So between that, if we can figure out quantum gravity from that, or figure it out through understanding the cosmological constant as the cosmological variable, in which I'll have to work more on my other framework when it comes to, emergence and convergence, as well as consciousness and the process of interactions, possibility, impossibility, just a bunch of different factors, and using geometry as well to create an equation to explain that type of movement of convergence and divergence, then maybe that's relative to that as well. As, I mean, that's at least my theory, my idea, going into the acceleration of the expansion of the universe as well as the deceleration of time, or time dilation itself. So it's more of a perspective of the 3D reality in a 2D sense. So a way that we can measure that regardless of the complexity within the universe, right? Kind of disregard that and to look at things in a statistical manner. It's weird. It's not necessarily per se. I mean, physics is technically statistical in nature because we're measuring things, we're getting data, and we're observing different aspects and having different equations to measure those different aspects so we can look at information. I mean, inherently, mathematics is a language for physics, and what physics is doing is a way of analyzing reality and understanding how things work, you know? And so basically it is a statistical analysis in that sense. So maybe with those two ideas in tandem, maybe something can come from it between the extremes of black holes and I guess the micro scale, as well as understanding things at the Planck scale, interactions which we can't really observe that easily, and then also understanding the entire motion of the universe itself because it's all relative. You blame Einstein for that. But anyways, if you like this, then like it. If you don't, then whatever. Look into this stuff yourself. You can argue with me in the comments below, or you can, I don't know, if you have any ideas as well that may relate to quantum gravity, any other theories or things to look up. I mean, sure, but obviously, right now, as of right now, nothing necessarily exists to describe quantum gravity. This is the best I got. And maybe it's better than what most other ones have. Maybe it'll work with other theories that other people have. I don't know, but eventually, when we break down each of these effects and start looking at the equations and just experimenting, I guess theoretically, maybe something can come of it. I don't know. But if you want to stay tuned for the ride, subscribe, like the video, share it, look up your own stuff. Let me know suggestions or other things to look up or articles, etc. down below, or just leave the titles down there. And yeah, just I don't know, man. Just stay curious, ask questions, get answers, and until next time, this is Spark saying peace.